Hi guys, this will be my first video and I've chosen to make it on Mechanica because I guess there aren't that many videos out for it lately. I was looking for one on the bodybot programming, couldn't find one, so I thought I'd have a go at it myself. So first thing, we're going to look at creating a bodybot that can transport items from this storage chest to this drop-off point here. So we need to place him, and because if you put batteries in straight away, he'll just hover and be pretty annoying. We need an elegant way of turning him on and off. So thankfully, or luckily, we can actually place a button right on his front like this. Now we need to link this up to the bodybot so we can use it to turn him on and off. And to do that, we need the options to turn him on and off, first of all, those functions. We also need to find the event listener from the button, so we know when the button is being pushed. And we need to figure out whether or not we're turning him on or off. Now, because there's two options, we're going to need a branch, which is also known as an if statement. So you can find that in the common functions execution control branch. You can see that we have this little red icon here, which means that it has to take in a setting or a Boolean variable like a true or false. And the one that we'll use is the isOn variable. This will tell us whether or not the body is actually powered on currently or is not. So we link these up. And what we're going to do here is, if the body is on, if that's true, if he's on, we want to turn him off. And if he's on, we want to, if he's off, we want to turn him back on again. So that's our very basic setting for turning him on and off. This particular body will need 4 sections. So one will be the button section to turn him on and off. The second one will be for actual transport between the box and the drop-off point. If there are items in the box, of course, but the thing is, if there aren't any items in the box, then he needs to wait around until things have been placed in there as well. So we're going to need to put in a wait function or a sleep function. And then we need another section which allows him to choose between which of those two options or tasks that he's going to do, either transport items or sleep and wait for more cargo in that box. So we're going to have 4 overall sections. This is the first button section. The one to transport from this box to the drop-off point is really straightforward and simple. All it is, we go into the functions, we go pick up item from storage box, surprisingly, and then we go to place item in drop-off box. And they're right next to each other. We don't need any go-to markers, any transport assistance or anything for him. We're just going to send him from one box to the drop-off point. So all we need to do is that. And that pretty much covers the module that we're going to build for him to transport between the two. Now let's say if the storage box is empty, we need him to wait, or to go to sleep really. So we're going to put in a wait command. In this case, as it's an example, I'm just going to set it to 5 seconds, so we don't have to wait like a couple of minutes to see him transport the items or whatever. I would recommend putting this to the highest number of seconds that you feel comfortable with. If you put it to the low number of seconds, he's going to be checking constantly whether or not there are items in here. He's going to wake up every 5 seconds. He's going to check, see if there are any items in there, and then transport them. Now you probably won't have items deposited in there every 5 seconds. You could do, who knows, maybe. It depends if this route is a high traffic route or if this box is a high traffic drop-off. So use common sense with this. If it's far away at the other side of the map, or if there isn't much throughput into this box, do set that time limit high because it will help with running processes in the background. I'll probably explain that a bit more once I put in the decision section here. We also want, with the wait section, with the sleep section rather, we want him to be able to turn himself off to save battery power. And then when he's off, he needs to wait. And then I suppose he will need to check and then turn himself on again if need be. First of all, he'll need to turn himself off and then go to sleep. So these are our three sections. Now we need the decision section, of course, as well. So when we turn him on, he needs to decide, is he going to pick up items from the chest or is he just going to sleep? And the way he works that out is to examine the chest, find out if there are any items in there. Now, if he was a human, he'd probably have to open the chest first, look inside the chest, see if there are any items, and then he will know what to do. But thankfully, in this interconnected world in here, we can go directly into the chest to see if it has any items in it. But to do that, we need to link up the body to that storage box. Just like that. So we can go back into the coding here, into the programming. Then we close this, and we want the linked object of the storage box this time. And we need to know what's in there. So we do get variable value for the storage box here, and we choose amount of, let me zoom that a little bit. So we choose the amount of stored items. That will tell us whether or not there are things in there. It'll either be 0 if it's empty, or it will be a positive integer if there's something in there. So again, there's an if statement here or a branch. There are two possible routes from this, so we need this branch again. Quick way to find this is to just right click it and duplicate, and that will bring open a new one for you. So you'll notice we actually need a Boolean setting here, and we get that by comparing this to 0. 0 means there's nothing in there. That's the most significant thing that we're looking at, and we need to compare it to 0. So we'll need a comparison here, which is comparing the numbers, and we want greater than. If it's at 0, it won't do anything. If it's anything that's greater than 0, positive number, then we can do something. Right, so we have these items again. So we put the variable into A, and the number that we're interested in, this is 0 currently because there is actually nothing in this box right now. So B here, this is the number that we're going to compare against. Comparing against 0 to check whether or not there are any items in the box. Great, okay. So then we run both these options into the branch. If the box is at 0, if A is greater than B, which it wouldn't be if there's nothing in the box, then it's false. So if it's false, we actually need to go to the sleep section. We put that to there. If it's true, if A is greater than B, if A is greater than B, then there are items in the box. Then we need to move on to the section where he's picking items up from the box and depositing them in the drop-off point. Once he has done one of these transports, we could loop him back to this, but that is assuming then that there are items in that box. And we can't simply do that, unfortunately. So we need to loop in the check once more. So he needs to go up to the test to see whether or not there are items in the box. If there are, then he will go straight back through to this. Oh, you'll also notice you have to set a certain box that you want, because obviously you can have multiple storage boxes. This doesn't automatically know which one you're talking about. It hasn't pulled it out of the linked objects, it's pulled it out of the bodybot functions here. So we do need to link it up somehow, and to do that, you probably worked it out already. Click set, that will allow you to select the box there. Then we need to do the same for the drop-off point as well, which is over here. Now, excuse me for a second, I can hear that we've got some vacuum cleaners outside, so I'll be a couple of minutes dealing with those and I'll be right back. So now we need to find out or figure out how these four sections interact with each other. What do they mean, really? The first thing that stands out is this wait section. We have a turn off command here, but we don't have a turn back on command. So once this finishes waiting, after it's waited, it actually needs to check again whether or not there have been items put into the chest. So you need to link it back to the decision section here. If there aren't any items, it will just go straight back to wait again, and it will put into sleep, and it will go around in this loop. So he will check every 5 seconds to see whether or not something has been placed in that chest. If something has been put in the chest, he'll need to turn himself on. So to tackle this, we can either put a turn on option here straight after the wait, but that's not really what we want to do because he might turn himself on and then back off every 5 seconds. That's eventually going to wear down our battery. So the way to do it is to only turn him on when he has discovered that there are items in the chest, in the storage box. We only know that after this branch, after this if statement, so we need to put a little calculation in here to figure out whether or not he is on or not. So we'll need a branch again. We can actually pull his on-off status from this variable, or from this command here, get variable. We'll plug that in straight away there. Let's get rid of this because we don't want to go straight into there. We actually want to go into these branches first, and then we can go into there. If he is, let's see, if he is on, then he can go straight into carrying out his function here. If he is not on, then we'll need to turn him on. And when he is on, then he can start working away there. Now there is another problem with this wait cycle as well. We're telling the body to turn himself off even though he is already turned off. Now that might be fine that we do this, and I think it actually is, but for good programming practice, it's probably best that you check here whether or not he is on or off. If he's on, then we turn him off. If he isn't, if he is off, then we can just go straight in and wait another 5 seconds or so. So we'll need another branch there to do that. Above it here. So we need to change that straight into here. And we need to check whether or not he's on or off again. Right, so with this, if he is on, then we need to turn him off and then go into the wait or the sleep cycle. If it's false, if he is off already, we just skip that out and we go straight to the sleep cycle then. The next thing I wanted to get into is function failure. What happens if something fails? So for example, if with this check here we didn't put in this branch, if the body is already turned off and then we try to run the turn off function, what happens here? Does this function fail and then execution fail to flow on to the next function? Or does it just ignore this and execution just flow on anyway? What happens here? Does that fail or does it not? If it does fail, it could fail with where we're turning things on. For example, if there is no power in the body, can he be turned on or not? If he does not have power, then turning him on with this function could easily fail. It's good to employ a few best practices with this and to just put in a few checks and balances just to make sure that we're not calling functions that are going to fail. Now I might not spot them all, I probably won't, but if I can see them, I'll put in some sort of guard against those. We can look for the variable which is, does he have power? So we'd need to put in another branch here, of course, for this one. So duplicate branch. We'll check if he is on first of all, because if he's on, we know he has power. But if he is not on, if it's false, then we need to check whether or not he actually has the power to be turned on as well. So we link this boolean up to this branch, we get rid of this, we go from here to there so we can check whether or not he's got power. If he's off and has power, then we can turn him on. If he is off and doesn't have power, then we'll just leave the false here because there is nothing more that we can do. He can't be turned on. We also need to add this branch in here as well. So let's just take a duplicate branch, run this down, cancel this line here, put the false to this run, and we also have already if he has power or not, so we can just take that value, plug it in here. If he does have power, then we can turn him on there. There's a second way to check whether or not something has worked. Now these would be more prerequisites to make sure that we have everything in place before we try to turn something on in order for the function to run correctly. That's good practice, but also before we go ahead and run all the other tasks, it's perhaps also good practice to just check whether or not this has worked and the body is now on. So we can, if we're going over the top with these checks all the time, you probably don't need to as much. I'll show you something else just after this bit which will probably confirm that we don't need to check it. If this turn on option fails, we need to check whether or not the body is on. So we can go from this done option into branch again. We need to check whether or not it is now actually on. If it's true, then we can continue with the tasks from here. I didn't actually put this in to start it all off, so I'll do that now. So we're checking if it's on, and if it is on, then we can launch into the decision of what he will do and then his life cycle. If it's false, then we know that the turn on function has failed and we're not going to go anywhere from that. Even though we've checked that the body has power, something unforeseen might have caused it. For example, maybe in a later update there might be water, it could be a river, waterfall, etc. The bot could be in that waterfall at the bottom of the lake or whatever, waterlogged, the electronics don't work. That could cause this turn on failure. This could also be considered best practice as well, especially in an early access, just to make sure that we're covering all bases. Also, we do have other turn-ons. There's a turn on here, so we can just put this in here, just for completeness. Put that under there. Get rid of this, put that straight in here. I'll get the is on variable. Put that in here. If he is on, if it's true, then we can go to work on collecting the items. Now this body bot will work away without us checking whether or not it has power, confirming whether or not he's turned on or whatever. I'm just kind of noting these things here just for best practice. For example, I know we're not programming an aeroplane here, but you really want to check whether or not an aeroplane has fuel, the passengers are all on board, the doors are locked, the wings securely fastened, etc. before you try and take off, because it's too late to confirm whether or not the plane has taken off, because, well, you'll have a disaster on your hands. So this, the prerequisites, this is definitely good practice, best practice for it, and just a confirmation just to make sure that the rest of what you're going through isn't hindered by it not being turned on in the first place. So you can have a check before and after one of these functions. Right, so there's one thing that I wanted to show you in relation to these functions failing or not. It's quite an easy test that we can run through, and I'll just put down another buddy bot so we can check that and see what actually happens here. So we'll put him there, we'll put a button on him, and we're going to set up the first basic setting again for use with the button. We need to know whether or not, actually, sorry, I'll do it in order for you guys. So we need the option to turn him on, we need the option to turn him off, we need a branch to decide which one of those two is going to happen. We need to figure out whether or not he is already on to decide which of these two we need. And we of course need the button event listener to see, so we know that something has been pressed on the button. Event evoked goes into branch. If he is on, then we turn him off. If he is not on, then we can turn him on. We're not putting any batteries in this new buddy, so we know that if we go to turn him on, we know that it's going to fail. We know that he cannot be turned on. We need to check whether or not, after this function fails, whether or not the code continues to execute after this. The only way that we'll see it, or one of the ways at least, there aren't many ways, probably as many ways as you can think of, but the way that we'll do it here is to change his helmet color, and we'll just change it to cyan. We know this function is going to fail on this body, so we'll go into execute and we'll see if his helmet changes to cyan after we press the button. Right, pressing the button. Because his helmet is now cyan, we can easily tell that if this turn on fails, if this doesn't work, then the code will actually continue on to anything else that we have below. So, for example, if this turn on failed, it's lucky that we have this branch and this check here, because if we didn't, this failed, the execution of this program would still run into this, even though the body was turned off, you see. So it is a good idea to have your checks. This could raise a thread on one of the processors, perhaps, that would just keep running this loop over and over. And while I've mentioned that, you might also notice that there is no point at which we are breaking out of this loop. We can see that even if the body is off, the code still executes. And that's a problem, because we've started off a loop, we might click it again, we'll start off a second loop, then a third loop, and we can have processes piling up in the background that will eventually slow our computers down and could cause memory leaks. If you pick up the body, I don't know if those loops automatically get cut short or not. So you may have some processes running in the background of this game taking up resources and you'll have no idea why. I think the only way to clear those off would be to exit out of your game, out of the level, but you'll also need to close down Mechanica, close down the application, just to make sure that Windows is closing any extra memory and doing its own garbage collection on it as well. The only downside, I suppose, is that you'll find things starting to grind to a halt a little bit. It may not lead to anything more significant than that. It probably won't, so I wouldn't worry too much about it. But that is definitely something to be aware of, and a good reason to make sure that you're including the relevant checks for this. The most important one is this, actually, just to confirm whether or not this has failed. In order for me to explain or illustrate the looping issue, I'm going to need to set up a bit of a random counter here. You don't necessarily need to follow along with this, but if you want to and work it out for yourself, see what I'm doing, then feel free. Just want to generate a random number here, and there are going to be 8 different colors that I'm using. I'm not going to use white and black, and I want to do a less than. So I'm going to put the variable in here. I want to find out if it's less than 1. I want a branch. If it's true, if the number is less than 1, then I just want to change the color to red. I also want tons of duplicates here. So let's see if that works. Turn it off first, turn it on. So we've got green. I'm sure you can see the colors for yourself here as well. Orange, etc. And we can see that's changing very slowly, every 5 seconds or so, back to green. Let's go into the code here. I've turned it off here. I have not interrupted this loop at all, but I have started a new execution flow on this panel within this lightbox. If these objects can only have a single flow of execution at one time, then we should find that this loop has been cancelled. If they can have multiple executions at the same time, regardless of being on or off, then we can click that box. We can click the switch multiple times and we'll see that this changes color way more often. So I'm just going to do this a few times. So I flicked this a few times, so if I turn it on, let's count how often this changes. If it lasts 5 seconds before changing, then we know that there can only be one flow of execution at any one time in an object. If it changes faster than that, then we know that we could have another problem that we need to watch out for. Okay, so that seems to be a pretty random change. That's a lot faster than 5 seconds anyway. Okay, so it's clear that we've kind of broken the loop, and whenever we turn it off like this, then we know that we haven't killed any of the execution loops in the background. We know that there are about 30 of these running in the background. We can actually see, look, the condition. The number here, the variable, is actually changing on us as well, and it's off. So this is a bit of a problem that we need to watch out for. This can definitely cause you glitches with whatever you code. So something that you'll definitely need to watch out for is keeping a closed loop like this and not having a breakpoint for the loop to end. So that is something else that we're going to have to tackle. We have a closed loop here in our buddy system, and we have no way of breaking out of that currently. So that is something that we're going to need to add. We need to figure out some place in this loop at which we can break the process. First of all, we can see that this is where the two loops converge. It always comes back to this decision. So we really need to put the break in here. And the place that would make the most sense is probably before we even run this comparison. So now that we've decided on the best location for the decision of breaking out of the loop, we need to decide how we're actually going to do that. If I was running in a programming language right now, I would probably set up another Boolean which would say pending stop. And I would set it to false currently, and anything which causes this loop to stop, I would then call a command to set that to true. And then whenever I'm running through this, I would check back at that Boolean, and if it ever said true, then I would I would end. I wouldn't continue with the loop any further. But we don't seem to be able to set up our own variables like that, unfortunately. We have another option. It seems that while we can't set our own Boolean variables, we might in fact be able to set our own numeric variables. The math options, or maths if you'd prefer, these options will give us the option of setting our own number variables that we can then use elsewhere. So the game crashed. I lost the body and everything else, but I've recreated it here. Hopefully it looks more or less the same, and we'll be able to continue on from this. I'm guessing it was probably caused by the flashing light, all of those color changes and that process just continually going on forever in the background there. I kind of want to set up a test to see how this will work. Again, I'm going to use light. I am going to link it up to the switch. Then I'm going to set up a basic on-off function for this light using the switch and listeners. Right, so I want to figure out whether or not we can store variables using those maths functions. So let's pull a couple in here. So I want to be able to execute this basically to make sure that I'm setting a variable, because otherwise it will just output 0 as we saw before. I want to add 1 to it because I'm going to count the number of times that the program gets turned on. I want to be able to save the number, so I was figuring out that this is obviously going to equal 1. So I want to save whatever is in here. Can't put it back here, which is probably fairly sensible that it doesn't let you do that. But what you can do is you can create a second one, and then you can pull that result down to here and it will store the variable here for you. Now you should be able to pull that variable back here as well. Now the execution flow is just going in one single direction, so that shouldn't cause issues. So what will happen is it goes in here, it adds the 0 and the 1, 1 becomes the result, execution goes through to the next one, it should pull in the number 1 here, it will add 0 to it, so it will stay as the number 1, and the next time this runs, maybe we'll see that the number 1 continues to exist there. This goes to turn it on, and it ends execution. This has followed through as we've expected it to. It set the result as the number 1 here. The result here is 1, but this hasn't executed again, so I'm supposing that this hasn't looked to here to pull the result in. But let's just turn this off once more and then turn it back on and see what's happened. Great, so this has gone to, it's pulled the variable up here, 1, added 1 to it, 2. So this is actually counting the number of times that we've turned the light on. So this is your basic counter, I suppose, and something that we can then use within the body to keep track of how many times that loop has started. we need to count the number of times that we have this loop started. So we can actually put them in place of this line here. Once the flow of execution goes down this line, then it's in the loop and we can't really break out of it. So this line needs to change, and we need to, let's just put them all up here. So add numbers, add numbers, add numbers, add numbers, add numbers. Oh my god, add numbers. Okay. I'm only doing the on count here first of all, so probably don't need all these. If true, if it did start executing, we want a 1 there. We want the result of this to feed in here, and the execution to go there. We want the result to go back here, and then this done is probably going to go on to here. So this one should start counting up the number of times that we start the loop. But we also need to figure out the number of times that we end the loop. So I've gone ahead and finished off the rest of the code here and cleaned things up a little bit. Not that it looks particularly clean, but there you go. You'll see the counters are slightly different. The number that I increment the counters by is showing at the top. I've just moved it around so they don't get obscured by all these function links all the time, so you can see what number is actually being incremented there. Now we've got 3 counters. This one in the middle will count how many times we're starting off the life cycle loop. The bottom one here will count how many times we've successfully ended the life cycle loop. And the top one, because we have a sleep cycle here, and if we're trying to stop it while it's sleeping, we could try and stop it multiple times, because there's no code that's being updated for at least these 5 seconds or so. So what I've done, I've added in a pending request, a pending shutdown request counter that we can compare one of the numbers with, and that will tell us whether or not we can actually put in another request to shut it down or not. Just because we might end up with multiple requests to turn it on and turn it off when this finishes, and it'll be a bit messy. This just guards against that. You'll see the comparisons are in to check where we are in the life cycle. What this will do is when we turn it on the first time, this will go up to 1, the others will be at 0. We compare here, and if the numbers are different, because this one will be at 1 and we haven't shut it down yet, then it will go into its life cycle of either sleeping or picking up from the box and dropping off at the drop-off point. When we click the button again to shut it off, then it will go straight to put in a pending request. This counter will go up by 1. Then each time we make it through the sleep cycle or the actual task cycle, it will check against this, and it will see whether or not the number of times that we've run the life cycle and the pending requests, if they are equal, then it will actually turn off the body properly and it will count up a successful shutdown. Now I've also added in some color changes here as well. So on a successful shutdown, I'm changing its helmet to red to show that it's actually finished its life cycle. If there's a pending one, it's going to orange. That should change to red after 5 seconds or so, or within 5 seconds if it's running through its life cycle. And of course we've got the green, which will show when it started its life cycle. I'll put some batteries in and we can test it and we can see how it works. I'll just pick up the other body to make sure that it doesn't interrupt the testing at all. And we're good to go. So I'll just put some batteries in and we'll see what happens. Now, as usual, when you put your first battery in it, it will jump up and turn itself on automatically, and that isn't exactly what we want, so we'll just turn it off. You'll notice I've linked up this screen as well, so this is displaying as 0 while it's off. I'll just turn it on, and the helmet should turn green, and it should start transporting items. If I press the button again, we should see his helmet turn yellow, and that will signify that we're pending a shutdown. And then it should turn red after he reaches a point in the life cycle, which it does there. Great, okay. We can turn him on again, and he should start processing once more. Now I'm just going to take these out. So he's checked that there's nothing in the storage box, so he's saving power, turning himself off, and he's gone into his life cycle to check every 5 seconds whether or not there are items in here, so he can turn himself on and start processing again. Now his helmet is green because that life cycle, that code is still running. So as soon as I put items in here, he should get up within the 5 seconds and start processing once more. Let's take them out once more, and this time we'll see what happens when I try to shut him down while he's in his sleep cycle. His helmet is orange, and it changes to red after the sleep cycle is finished. So we can try and turn him on again. There are no items in there, so let's see what happens. He turns on, he goes into the life cycle, but he goes straight to the sleep cycle because there's nothing in here. Let's turn him off. Orange pending. Red, he's shut himself down. Let's put items back in here, and here we go. And he'll finish off transporting the rest of the items. Well, the main problem is he only transports one item at a time. So do we set multiple buddies up with this route, or do we do something a little bit more creative? And something which would be more useful for long distance transportation. Here's the finished code. You can leave on the link to the large screen if you want, as some sort of monitor as to whether or not the buddy bot in question is working away. I'll zoom in. I'll do a scan around this, so feel free to copy it and use it as you will, as you want to. It would be nice if we could save this as a template and then move it into any new buddies that we create. But maybe, hopefully, that will be something that becomes available in the future with a future update. Also, comments would be really nice, or headings, or just something where I could put like a heading just to say that this is the counter for the pending shutdown requests. This is the counter for the start of the life cycle. And this is the one where the life cycle ends. That would be great, have comments in here. And groupings perhaps, just to show that this together here is the sleep cycle. This is the decision cycle. And this is the task cycle. So if you're copying this, you might want to note that we have 40 functions, 73 function links, and 3 linked objects. One of which is the large screen, which you don't necessarily need, but you do need the button and the storage box that we'll be picking up from. So if you want to copy this, just compare these numbers, make sure that we have all the same links. If you don't put the large screen in, you'll have one less function, so you'll have 39, you'll have 2 less function links, or 2 fewer function links I should say, so that goes down to 71, and that will be 2.